Hello, this lesson is for Algebra 2, and it's entitled Solving Inequalities, and it's Chapter 1, Section 5 in your textbook. And we're going to dive right in. Solving inequalities is a lot like solving equations. The only thing that is different, there's actually two main things that are different when you're solving inequalities. One is your solutions. In an equation, you get what we call finite solutions. And I'll just show you what I mean after we solve this one. So, how do you solve an equation? You do the opposite of what's being done. Negative 6 means subtract 6. So we're going to do the opposite of that, which is to add 6 to both sides. So y is less than 9. Okay? Now, why is this different than if you had y minus 6 equals 3? Not a whole lot would be different. You would still add 6 to both sides, and you would still get 9. But how many numbers are actually equal to 9? Yeah, 1. That's called finite. It's a countable number of solutions. It doesn't have to be 1. Sometimes with quadratics, you can get 2 answers. You can even get 3 or 4 answers. But at the end of the day, they're going to be finite. They're going to be countable on your fingers, okay? The difference between that and infinite solutions is that in the case of infinite, it means that it's not countable. It goes on forever. You cannot count how many solutions there are. And so, how many numbers are less than 9? There are an infinite amount of numbers that are less than 9, which is evident when we graph the solution on a number line. So what you want to do is have a marker that works. Okay, we have our number line. It's kind of crooked there, but you get the picture. Now, I'm not the pickiest person when it comes to number lines. There are a few things that I need to make sure that you have accurate on your number line. Is that somewhere on the number line there should be a 0, okay? So it doesn't have to be in the middle, but there should be a 0. Like in my case, I don't want to draw the biggest number line known to mankind. So I'm going to go ahead and put my 0 more off to the left because 9 is further to the right. And if I put it in the middle, I'm going to have to go even further. So that's why I put the 0 over there. But again, you can put it in the middle if you'd like. This is just how I want to do it. But somewhere on your number line, you should always have the 0. And then, of course, the number in question, which is 9. So somewhere on the positive side, I want 9. Okay? You'll probably remember that when you have a less than or a greater than, that your circle or dot is what we call open. It's not shaded in because we do not want y equal to 9. We want y less than 9. And then there's a couple of ways that you can do this. Some people shade. Less than 9 would be this direction, so we shade that direction. Another option is to draw a little arrow that indicates that you are going to in the left upward direction there. But again, the arrows in both cases indicate that the numbers are going that direction forever, infinitely, and therefore we don't have a finite number of solutions. So that is one of the first things that is different about inequalities is the number of solutions that you get. The second thing that is different, oh, by the way, this is your do-it-yourself problem, sorry. You can do that. My bad. The second thing that is different with inequalities is that sometimes you have to reverse the inequality symbol. And you have to reverse the inequality symbol anytime that you multiply or divide by a negative value. It does not matter if your final answer is negative or positive. That is not what qualifies you to reverse the symbol. Anytime you divide or multiply by a negative, you need to reverse that symbol. Even if you divide or multiply by a negative 2 times in the same problem, it means that you have to reverse the symbol 2 times. Okay? So here's an example. This is negative 4.2x. And in order to solve the problem, I have to divide by negative 4.2. And because I am dividing by a negative value, I am going to get a positive x, but this symbol, which is currently less than or equal to, is going to have to switch to a greater than or equal to. That is the second thing that is very different about solving inequalities. You would never do that in an equation situation, but you do in the inequality situation. So we're going to take negative 29.4 and divide it by negative 4.2 and get positive 7. Awesome. So again, if you're dividing by negative or multiplying by negative, switch the symbol, reverse the symbol. And then we have our solution here, and we're going to graph our solution set. Remember again to put the 0, put the 7, and this time we have a greater than or equal to. So our dot is going to be solid, indicating that we are including 7 in our solutions. And then we can shade to the right because it's greater than, or we can draw our arrow to the right because it's greater than. Okay? So that is how you solve when you've got negatives involved. So now you can try this do-it-yourself problemo. Don't forget to reverse your symbols if you need to. And then we have example 3. And example 3, I think, is our last example. So this is a very short lesson today. Example 3 is a multi-step inequality. We have more than one step involved. The first few we only had one step involved. So these are the ones that are more fun, if you will, okay? And I'm pretty sure that right now you're freaking out because you see that crazy fraction right there. But have no fear, we will get rid of said crazy fraction very easily by multiplying both sides by a positive 6. Now, you will notice that this is negative 4c. But we are not going to flip the symbol, at least not yet. Because we are not multiplying by negative 6, we are multiplying by positive 6. So 6 times negative 4 is negative 24c. No switch of the symbol. No switch, at least not at this point. Okay? Then the 6 divided by the 6, so these 6's cancel. So you have no more fractions. So you see, you no longer have to be afraid of the fraction. It is gone now. And we can proceed like usual. All right? So we are now going to subtract 5c from both sides. Now, if I really wanted to, I could add the 24c and then subtract the 58, but that just seems like 2 steps when I can just be done in 1 step, so that's what I'm going to do. So 5c minus 5c is 0. This is less than or equal to 58. And over here we've got negative 29c. Okay? Now, at this point, we are going to, in fact, divide by negative 29 to get the c by itself. And because we are dividing by a negative, now we flip the sign to a greater than or equal to. And 58 divided by negative 29 is negative 2. Alrighty, so there's our solution. And then we want to graph it on the number line. So this time, because my number in question is negative 2, my 0 is going to be on this side, and my negative 2 is going to be on that side. And it isn't equal to, so I'm going to make it a nice big solid dot. And then greater than negative 2 is going to be this direction. Or if you like the arrow biz, you can do that. Greater than or equal to negative 2. And that, my dear fellows, is how you solve inequalities in a nutshell. You can now try these. Remember, don't be afraid of these crazy fractions. Just multiply both sides by the denominator, and you will get rid of your fraction and be on your merry way. So once you have completed these examples, you will have completed your notes for this section, and I will see you in class. Thanks for watching.